Right now, the global race to build things like electric vehicles and deploy advanced AI, it isn't actually being held up by a lack of high-tech microchips.
Right, or even a shortage of rare earth mines, which is what you usually hear about.
Exactly. It's actually being stalled by a lack of incredibly basic industrial chemicals and, the fact that it rained a little too heavily in Angola.
It is a really striking reality check. I mean, we tend to focus entirely on the brilliant engineering of the final product, but we kind of completely ignore the fragile physical reality required to just build it in the first place.
Yeah, and that's exactly what we're digging into today for you because when you scroll through the news, you get these fragmented updates, right?
Yeah, a spike in global shipping delays here, an energy shock somewhere else.
Right, or like a local protest over tech infrastructure. And it all feels totally disconnected. But today, for this deep dive, we are taking a stack of structural analyses and looking at the underlying architecture.
We really want to understand how the global supply chains, the energy networks, and even urban infrastructure are actually wired together beneath the surface.
Because the traditional narratives, they just aren't holding up anymore. We're not here to chase the headlines today.
No, absolutely not. Today converges into three structural shifts. And, we aren't going to get bogged down in the political noise or debate whether these global movements are inherently good or bad.
Yeah, we're staying totally neutral on the politics. We just want to impartially unpack what the sources are actually saying.
Exactly. Instead of right or wrong, we are looking for gradients. We want to identify exactly where the pressure is building in the system and structurally where the flow of the world is getting blocked.
Let's start with the first major shift, which fundamentally redesigns how we have to think about energy security. For decades, global energy security was mostly about geography and stockpiles, right?
Right, like do you have oil in your territory and can you protect the ships carrying it?
Yeah, exactly. But look at what is happening right now. Japan is rolling out a massive $10 billion framework to help Asian countries secure oil and build regional stockpiles.
And the scale of that is staggering.
It really is. They are aiming for capacity equal to the entire ASEAN region's annual import volume,
Yeah.
which is about 1.2 billion barrels.
Right. And at the exact same time, the IMF's Kristalina Georgieva notes that they're dealing with over a dozen countries, primarily in sub-Saharan Africa.
So wow, over a dozen.
Yeah, and they're expected to request between $20 and $50 billion in emergency aid. And the catalyst for that, it's energy shocks rippling out from logistics disruptions in the Middle East.
So wait, what connects Japan's proactive billion-dollar investments and the IMF's reactive bailout packages?
It's a profound realization about vulnerability. In the past, if a nation had money, they could buy fuel. But the recent disruptions in the Red Sea and just the broader Middle East have completely fractured the shipping lanes.
Right, because commercial vessels are being forced to reroute around the entire continent of Africa to avoid the conflict zones.
Exactly. And when you do that, transit times double. Shipping insurance skyrockets.
So it's not actually a production problem, like the oil is coming out of the ground just fine.
Precisely. It's no longer about price, but access capability.
What does that mean in real life?
Yeah.
Because intuitively, if a country has the budget and the oil exists in a well in the Middle East, a transaction should just happen.
You would think so. But supply exists, yet cannot reach where needed. Let's break down the mechanics of that access capability. Securing a resource is now entirely about the intermediate layer.
Okay, the intermediate layer, like what specifically?
Well, it's the maritime insurance markets that agree to underwrite a tanker's journey. It's the regional port infrastructure capable of handling massive offloads when the delivery schedules get chaotic.
Oh, I see.
Yeah, and it's the trade finance networks processing the letters of credit. If any part of that logistical or financial layer fails, the physical barrel of oil might as well not exist. It just becomes stranded.
That makes total sense. So, to put it in terms for the listener, is it like having plenty of money in your bank account, but the ATM network goes down, so the money is effectively useless to you?
That is a perfect analogy.
Yeah.
Yes. The money is there, but you have no access capability.
And the ripple effects of that stranded oil are terrifying. When you really look at the mechanisms, it isn't just about the cost to, fill up a delivery truck.
No, it goes much deeper than that.
Right, because natural gas and petroleum products, they're the foundational feedstocks for things like urea, which is absolutely essential for making agricultural fertilizer.
Exactly. So if a sub-Saharan African nation loses its access capability to that energy, the fertilizer plants just shut down.
And if the fertilizer plants shut down, crop yields plummet a few months later. So a maritime insurance spike in the Red Sea directly translates into a localized food crisis in Africa.
Which is exactly why Japan is spending $10 billion on a regional safety net. They recognize that depending on a single, highly extended, just-in-time delivery route from the Middle East, it's just an unacceptable risk now.
They are buying resilience in that intermediate layer.
Yes, exactly.
That is fascinating. And, for you listening, when you see gas prices or food prices shift, don't just look at the raw commodity anymore. You have to look at the hidden delivery and financial networks that actually allow it to reach your local economy.
Right, the intermediate layer is everything.
But what I find truly wild is how this exact same vulnerability and this breakdown in the hidden intermediate layers is dictating the pace of the most advanced technology sectors on Earth.
Which brings us nicely to the second shift we're tracking, the physical bottleneck in the electric vehicle and semiconductor supply chains.
Yeah, let's talk about the EVs. The intent from global powers is incredibly clear right now. Like, the European Union has just launched this new joint procurement platform to aggressively secure critical minerals.
Right. Battery materials, rare earths, they're trying to decouple from single-source providers.
Exactly. And in the U.S., Treasury Secretary Bessent is actively pushing the World Bank to prioritize funding for these specific mineral projects. They are throwing massive amounts of capital at extraction.
Everyone is rushing to dig copper, lithium, and cobalt out of the ground.
But there is a glaring contradiction playing out on the ground in the sources. Take the Democratic Republic of Congo, the DRC, which supplies a massive percentage of the world's cobalt.
Their production is currently highly constrained.
Yeah, but it's not because they can't find the ore. They have absolute mountains of the stuff. The entire multi-billion-dollar operation is being choked by a shortage of unglamorous, highly basic industrial chemicals.
Right, we are talking about compounds like sulfuric acid and sodium metabisulfite, commonly known as SMBS.
Wait, if they have the rock out of the ground, what exactly is stopping them from just putting it on a train? Why are these specific chemicals the absolute deal breaker?
Because of a process called wet processing or hydrometallurgy.
Okay, lay that out for me.
Well, when you mine for cobalt or copper, you don't just dig up pure chunks of shiny metal. You dig up thousands of tons of dirt and rock that contain really fractional percentages of the valuable mineral.
Right, mostly dirt.
Exactly. To extract the metal, you essentially have to give that crushed rock a massive continuous chemical bath. And SMBS acts as a crucial reducing agent in that chemical leaching process.
Oh, wow. So without a constant, massive influx of these solvents, you just cannot process the ore at all.
You just have a useless pile of really expensive dirt.
And where do those chemicals even come from?
Many of them are imported via the exact same global shipping lanes we just discussed in the energy segment.
Oh, man. So when maritime logistics in the Middle East get disrupted.
The container ships carrying basic sulfuric acid are delayed by weeks. The mine's chemical bath runs dry and production completely halts.
The bottleneck moved from extraction to processing.
Exactly. The bottleneck moved from extraction to processing.
So things exist, but can't be produced. I mean, we hear so much about the race to mine these resources, but you're saying the actual vulnerability is in incredibly boring things like chemical solvents.
Yes, this is the entry point of nonlinearity.
Okay, nonlinearity in a supply chain context. Break the mechanics of that down for me, because that sounds intense.
Well, what's fascinating here is that in a linear system, an input matches the output, right? If you invest 10% more capital into mining equipment, you expect a roughly 10% increase in raw ore.
Sure, that's just basic math.
But nonlinearity means the outcome is wildly disproportionate to the cause. We have built this incredibly fast, highly capitalized global demand for advanced tech, but it is entirely dependent on a slow, physical, and highly constrained middle layer.
And when that middle layer breaks, the math just stops working.
Right. A delay in a shipment of cheap SMBS, a chemical that costs mere pennies relative to the final product, can completely halt millions of dollars of cobalt production.
That is incredible.
Yeah.
And the fragility doesn't even stop at the processing plant. Like, let's talk about the Lobito corridor in Angola.
Yes, the transport route.
This is a massive Western-backed railway project explicitly designed as a geopolitical transport route to move these processed critical minerals out of Central Africa and into global markets.
Bypassing certain rival ports, yeah.
Exactly. It is a vital artery for the global tech transition. And it was completely paralyzed recently. Not by a cyber attack, not by a trade embargo.
It was stopped by localized flooding. The tracks literally washed out.
Right. Just simple flooding. A flooded dirt track in Angola can pause the manufacturing schedule of an electric vehicle plant in Germany.
It's a massive shear, a friction between the speed of digital markets and the reality of moving heavy things across physical geography. The market prices and the value of the final semiconductor, but all the actual leverage rests with whoever controls the processing chemicals and the transit corridors.
The leverage always moves to the narrowest point in the funnel.
And as we transition to our third topic, we see that this friction isn't just limiting how we manufacture technology, it is violently limiting where and how we can actually use it.
Yeah, the urban OS backflow. I am so fascinated by this concept from the sources. We tend to think of artificial intelligence and the cloud as, like, ethereal digital things.
Yeah, they live up in the ether.
But the reality is that the cloud is heavy industry. It is massive concrete buildings packed with servers that run incredibly hot. And the global ambition to dominate AI is currently colliding head-on with the geographical and civic realities of individual cities.
We're seeing a profound tension between macroeconomic imperatives and local municipal infrastructure. Let's look at the mechanisms driving this in three specific locations. First up, Seattle.
Okay, let's unpack this. Right now, Seattle is reviewing proposals for 5 massive new data centers, and the aggregate power demand for these facilities is around 369 megawatts.
To put that in perspective for the listener, that is the equivalent of adding the electrical draw of roughly 300,000 homes to the grid overnight.
Which is just insane. The municipal power grid simply wasn't designed for it. The strain is so severe that Seattle is having to structurally rewrite its municipal power contracts.
They are basically telling these massive tech conglomerates, if you want to plug your AI infrastructure in here, you have to personally fund the upgrades to our civic grid.
Right. The city is acting as a protective membrane. And then consider the political dimension playing out in Paris, specifically the Le Bourget area.
That's a perfect example of the disconnect between national ambition and local reality.
Totally. The French national government is aggressively courting data centers. From a top-down perspective, they view hosting AI infrastructure as a non-negotiable requirement for national economic competitiveness.
But at the local neighborhood level, it has become a fiercely contested local election issue.
Yeah, the residents are pushing back hard. They don't care about national AI sovereignty. They care about the constant low-frequency hum of industrial cooling fans. They care about the ambient heat radiating from the facilities.
And crucially, they care about the economic reality versus the promise. A data center has an enormous physical footprint, but it boasts incredibly low employment density.
Right, you might build a facility the size of several football fields, but once it's operational, it only requires a few dozen permanent employees.
Exactly, just for security and basic server maintenance. The local community shoulders the burden of the infrastructure strain without reaping the traditional benefits of a large industrial employer.
Which turns a massive national economic win into an immediate local political liability.
National policy pushes, but cities resist.
So the friction appears locally first. I mean, imagine your own local city council suddenly having to debate global AI infrastructure because the local reservoir is dropping.
Exactly. Cities react before systems adjust. Which brings us perfectly to Austin, Texas, where the constraint is arguably the most vital resource of all.
What?
Water.
Right. Austin has transformed into a major hub for Tesla, SpaceX manufacturing, and all these new AI chip plants. But what people often don't realize is how a data center actually functions.
Yeah, to keep thousands of AI chips from literally melting themselves, facilities use massive evaporative cooling systems.
They're constantly evaporating millions of gallons of highly purified water just to reject the heat.
Which puts the tech sector in direct structural competition with the city's overall growth and water planning. The local reservoirs have a fixed physical limit.
It perfectly illustrates that concept of membrane tension you mentioned. The national governments and massive corporations are the pressure pushing downward with limitless capital.
But the local civic infrastructure, the water permits, the zoning boards, the power transformers, that is the membrane. And right now, it is stretched to its absolute breaking point.
It's wild to think about. The global advancement of AI is currently capped by whether a municipal planning board in Texas is willing to issue a water variance.
That's exactly it. The true limit to AI isn't the ingenuity of the software engineers or the theoretical physics of microchips. It's the physical capacity of the local urban OS to literally water and feed the servers.
When we pull all of this together, when we synthesize the energy redesign, the EV mineral bottlenecks in Africa, and the municipal pushback against AI data centers in places like Seattle, A really consistent pattern emerges across all three topics.
It does. If you look closely, the root problem in all of these scenarios is almost never a lack of raw material, and it is never a lack of final consumer demand.
So what is it?
Bottlenecks are shifting layers. They are migrating inward, moving from the ends of the supply chain right into the middle. Historically, we worried about the absolute ends. Can we find the oil, or will someone buy the car?
Right, supply and demand.
But today, those ends are relatively secure. The friction has lodged itself firmly in the intermediate layers. The visible problems that dominate the news cycle, a sudden spike in fertilizer prices, a delayed tech rollout, a political protest in a Parisian suburb, those are merely the downstream outcomes.
They aren't the root causes.
No, they're just the symptoms of a blocked middle layer. The key is where things get stuck.
So the key is where things get stuck. In an intensely complex, interconnected global architecture, true value and geopolitical leverage no longer default to the entity holding a raw resource.
Exactly. Power lies with whoever commands the connecting tissue. It belongs to the nations that build regional financial safety nets for shipping.
Or the companies that secure the mundane chemical solvents required for hydrometallurgy.
And it belongs to the local municipalities that control the civic infrastructure, allowing the digital world to physically exist.
You know, that completely reframes how you have to process information from now on. For you, listening to this, it gives you a new, highly effective filter for the daily news. Tomorrow, when you see a headline about a massive tech valuation or a new geopolitical mining initiative, don't just accept the grand top-down narrative.
Look for the hidden friction points.
Yeah, look for the unglamorous middle steps. The insurance premiums, the chemical reducing agents, the local water permits.
Where should we look next?
At the points where flow might stop. That is the ultimate lens. And it leaves us with a fascinating and maybe slightly unsettling thought for you to mull over as we wrap up today's deep dive.
Yeah, what's the takeaway for the listener at home?
Well, we've spent this time analyzing global shipping lanes, African railways, and massive tech shifts. But I want you to take this structural lens and look right out your own front window. As national governments and trillion-dollar corporations continue to force these massive technological and energy transitions from the top down, take a hard look at your own local city's infrastructure. Is your town's aging water supply or your local power grid destined to become the next invisible choke point in a global superpower competition?
It's a very real possibility.
It really is. Thank you so much for joining us on this deep dive. Keep questioning the physical structures behind the digital stories, look for where the pressure is building, and we will catch you next time.